GM, everybody. Hope you're all having a great day. Welcome. My name is Yasen, and we are kicking off the second week of the Fuel Hackathon with another workshop. Today we're going to be talking about how to index data on Fuel in less than 5 minutes, and we have Dimitri from Envio who's going to be teaching us how to do so. Dimitri, I'm going to quickly invite you on stage as everybody ends up still joining.
We are going to talk about indexing data on Fuel, and the way I want to have this workshop is we are going to start with me telling about what's indexing and why is it needed, what are alternatives you can use. Then we'll have a short breakdown session where you can ask questions, and I'll try to give my best possible answers to you. After this, there is a plan to have a live coding demo session, and where I'll show how fast you can use Envio as a product we are building to actually create an indexer for the Fuel. And the title says that it's possible to do less than in 5 minutes. It's a little bit clickbaitish because it's possible, but I think
we'll hold you into that one.
Yeah, I'll spend some time explaining you so you have the most possible experience. And if we have time afterwards, I'll show how it's possible to host it in a few clicks and have a running indexer ready for production. And yeah, in between, I'll also have Q&A sessions, so feel free to ask any questions during my presentation, and I'll answer them, like definitely at least something. Yeah, let's wait 2 more minutes. And while we're here, I'm curious who is listening to me, whether you're builders or like you're preparing for like gathering ideas or something like this. Are you ready for production or still building some prototypes or something like this? So
that also might be a good section to add that all of you that will be building and participating in the hackathon, we will be expecting your idea submissions at the end of this week. So basically, what our expectations are that you will go through all the previous workshops, get to understand how to build on Fuel, what to build on Fuel, get some ideas from all the workshops we're having. By the end of this week, we will expect the ideas that you would like to develop during the next 2 weeks, which are going to be the coding part of the hackathon. Also, as I said, don't be a stranger. Feel free to say what you plan to build on and what the stage of it, what the stage of your project is. Again, this is a hackathon open pretty much to everyone to attend, and yeah, don't be afraid to share your progress.
Okay, I think people will join a little bit later. And for now, I'll start my presentation because the last time I didn't manage to finish on time, and I don't want to take your time more than needed.
No worries, we're quite flexible.
Here's my screen. Do you see it?
Loading a bit. Yes.
Cool. So let's start. And a little bit about me. My name is Dimitri. I'm a chat dev, to say it simply. Also, I'm a Rescript language ambassador, contributor, and ecosystem builder. I created the fastest parsing library in the entire JavaScript ecosystem called Rescript Schema. And also, I built Envio, the Envio product, which is the fastest blockchain indexer on the market. I can proudly say this because it's true. Okay, but it's the least interesting part. So let's continue and tell about why indexer is needed and what it is in general. So for us as smart contract engineers or the app developers, we are really like, I need to think about multiple things, like think from different perspectives, because there is a cost of gas, and it means if we write some heavy logic, users need to pay more, Also, there is the cost of fetching data, which is also cost something. And if we want to create some cool apps, we need to read data from smart contracts and we need to pay for this. Also, what's important is availability of data, that we can get data first fast, have it reliable, so we should know that it's always available. We should know that we don't have huge latency, and also that it's in the format we want to use, like the most convenient format for us, and that we even have this data, because sometimes we want to use some data, but it's not on chain and we just can't read it. There are quite many things to consider. And when we design a smart contract, we really need to sit on the three chairs, I would say, like off-chain, compute, gas fees, data availability, and need to put the design somewhere in the middle of it to have a really good smart contract and a product built around it. And indexers help in it, and now I'm going to tell you why. But first, let's start with alternatives, and the simplest one is reading directly data from the smart contract or from storage. And here's an example how it's done on Fuel, and it's actually quite straightforward. You need to, on the left side of my screen, you can see some pieces of code extracted, like taking a screenshot from a contract where we define storage data, the storage of the smart contract, and this is a counter field, which is a number with default value 0, and then we can implement the contract by adding read-only method, which gets this counter and reads it from storage. And then on the user side, for example, on our front-end application, we can use Fuel's TypeScript SDK, where you feed it an API and it will generate you some functions to work with. So it can just simply be us getting a contract and calling a count function, which will then return us a value. But there are some issues with this. I don't say that this approach should be avoided in 100% of cases, because actually I know there are some applications that use this and it works perfectly for them. And this is actually the best approach for applications which want to be truly decentralized. But still, it needs to consider that there are some trade-offs, and here I want to list them so you can consider whether this is important for you or not. And first one is that it's limited by gas usage, and even though technically reading the contract data is free, it's not always the case. Also, when we read data from storage or a smart contract, in smart contract, storage is optimized for storing data instead of reading, because actually the storing is the most gas expensive operation compared to reading. And what it means that when you read the data, you get it in a very inconvenient state. Like you get either like you need to map the data or connect some pieces together, or you need to do multiple read requests, like read calls, to get everything you need. And also, for example, if you know that your application needs some data to work with, you must to put it on storage. While with indexers, it's not always the case. For indexers, sometimes you can ignore, like you can use the data not added to the storage, which is pretty cool. Also, long response time, and even though with Fuel network, it's situation improved, because it really executes fast, but still, like when you read directly from a contract, you need to make a, usually it's RPC request for EVMs, but for Fuel, it's they have GraphQL API, so you need to call a node, and then it will respond you, so you don't really know how much time it will take, and also you don't know, I think the main problem is how much time it will take. Also you get only the latest state of the contract, so you can't get like historical state, or for example, or when some operation was called, like the time of it, unless you specifically store it on the contract and pay additional gas costs, so really expensive. And aggregation and filtering, so quite often if you have complex UIs or want to have analytics, it's really requires you to get like multiple calls to the contract. And also it's impossible to get this historical progress, for example, how for example, contract state changed with time, like really useful for analytics cases. And the solution is logging and indexing. And how it looks like, here's the most simplified flow I could come up with. And here on the left side, we have a user, and the process moves to the right side. So a user performs a transaction to a smart contract, an RPC call, as I said, or GraphQL or whatever. It doesn't matter because it's different, like for Fuel, EVM, and other things. And when a function on smart contract is executed, it produces receipts, or if you're familiar with EVM, it's called emit events. But for Fuel, they are called receipts, like log data receipts, which we use most often for indexing. And then these receipts are queried by the data indexer. So a data indexer is a separate service which runs, and for the specified contract and specified params, it gets all the receipts or emitted events which happened on a smart contract during like all this blockchain time historically, and then it continues getting them on the head. And all these receipts, they are aggregated and stored in a database. It can be Postgres or ClickHouse or whatever, anything you want. Otherwise, information useful for your application to work with, or information you want to use for analytics. And then this data can be queried by other applications, for example, via a GraphQL API layer or REST API layer. So there are really multiple ways. But sorry. But in a nutshell, indexing, I think a good analogy will be like an indexer of important documents. So you get all this data which happened during the lifetime of your contract, and you store it in a convenient way for your applications to use. And it's like a big library or something like this. And if for the ones who are familiar with EVM, I have a short comparison of how it's different, like how Fuel is different to login for EVM chains. And here's like on the right side, you can see an example for Solidity. And for Solidity, we need to declare an event first, and we need to use the event declaration. And then you can use only this event declarations to emit an event and like pass the data there. Also, there are some index fields, some not index fields. So it's quite confusing. And actually, the way how the Fuel team does this is really cool and much more flexible. And you can see it on the left screenshot. What you need to do in Fuel, and here's, you can see Sway instead of Fuel. And what Sway is, it's a programming language used to create contracts for the Fuel ecosystem. It's really similar to Rust, and it's based on Rust and adjusted to be. And here you just simply need to call a log function, and you can pass anything in this log function, starting from undefined, if you speak in JavaScript language, or like a string or a struct. So here we just create a struct, define a struct type, and then we create it and we can log it. So literally anything you want, like nested structs or unions, variants, or like, I call different names because in different languages these are called differently. And what about logging? Because I said that storing data is expensive, but what about gas cost for logging? And here's a tweet of the Uniswap creator, and he asks, is it worth removing events and moving to cold traces for Uniswap v4 for 1% gas savings on all swaps? And like, you can see that for Uniswap, it's like very, I think one of the most popular contracts at all. Simply like removing logs is only 1% gas savings. And I don't know how exactly it is for the Fuel, but I think it's pretty similar for like pretty similar costs. And I remember I was looking at the gas cost table, and logging data was very similar to, in terms of cost, to reading data from storage. So it's like something like this. And on the tweet, you can see that 50% answered yes, but that's not true. And the author says below that poll suddenly flipped by a wide margin last minute, so probably it was botted. And people don't want logs be removed because they're heavily used. Yes, let's continue. Yeah, I just remembered that a funny comment I had in another presentation like this, saving even 10% of gas by removing logs wouldn't force it, because yeah, it's really powerful. And yeah, talking about logs and how they look actually on the chain, we can take a sneak peek at the Explorer. I have a link here, so I can even share it to you so you can play around, but let's take a look at it together for now. So let's go back to the slide. So when a user calls a smart contract, it actually ends up in a transaction, and a transaction during the execution contains some operations. For example, it can have a call of some contract method, and then a call can have some nested operations. And what we are the most interested in are log data operations, or otherwise, like in other ways, they're called receipts. And here's a receipt object and a lot of data. I think the most interesting here for us is the ID of the receipt, which is like a unique identifier we can rely on. Also, the type of receipt is log data, and there are many different receipt types. And currently, the most used for indexing is log data, but also I know there are cases for transfer in, transfer out, min, burn, call receipts. And yes, you can also use them for indexing. And also another interesting field is RB. And for the ones familiar with EVM ecosystem, this is topic 0. and the data field, which is decoded, which is encoded, sorry. And for decoding this data, you can use either Fuel's SDK, like TypeScript, Rust, or any, they have multiple languages. Let's go back to, presentation. And I'm talking about indexers. Like the simplest way is to just start calling a GraphQL API to get all these receipts. I'll go back to them. The most straightforward way to create an indexer is to start requesting receipts for a specific contract and then decoding this data on the client using TypeScript SDKs and storing it in the database in the way you want. But the problem, like there are multiple problems. First, it will take really huge amount of time first because you need to do a lot of API requests, there are rate limiting, also there are like limitation, unless you host your own nodes, there are, for the public GraphQL, there are limitation on the complexity of the query. Also, it takes time to decode data. Also, there are no types and for the data, and storing it into database also take times. And all those problems, we solve them in our product Envio, which provides a really quick start, which I'm going to demo in the next session. Also, it provides a super nice developer experience by generating all the types for you, doing all this decoding automatically. So you simply need to write only the logic of converting the decoded events data into entities which you want to store in the database and using either GraphQL or REST API. Also, we solve the problem of querying. Like under the hood, we use our other product called Hypersync, which is like super fast. So if you compare it, EVM RPCs is like 1,000 faster than simple RPC. So yeah, also we sync all the entities synchronously, so they are in the correct order. Also, we have batching or when we store entities in the database, so like the indexer is really fast, and I'm going to show it you in the next session, which is going to be a live coding. And for now, I'm going to take a look at the chat. So what's going on here? Does Envio works like subgraph? Under the hood, it doesn't work like subgraph, and it works like there are some advantages compared to subgraph, and the first one is speed, and also the simplicity of usage it. But from the user perspective, it's pretty much solves the same problem. Yeah, no questions here. Also, if you have any questions, you can use the questions section. And I'm going to have a sip of water and continue with the live demo. Okay, so for the live demo, what we're going to do, I found this SwayFarm smart contract, which is built by the Fuel team. And let's go to the GitHub. And it's a fully decentralized game built on Fuel, so you can harvest items and like all operations are done via their smart contract. Buy seeds, sell items, and etc. And every time you sell an item, you get farm coins. I think it's 10 coins per tomato or something like this. And this app and this user interface reads directly from the smart contract. But for this specific case, for example, if the Fuel team wanted to build, for example, a user profile or for example, a leaderboard of all users, they would really be limited by the design. And the only solution here is to have an indexer. And I think it's a pretty nice and simple use case. So let's build an indexer for the SwayFarm application, which can be used for creating a leaderboard. And we can see how simple it is with Envio. And to start, we need to open a terminal and run npx envio init. Then it asks, what's the name of the indexer? Let's have it full demo, and which folder we want to put it in. Let's put it in the SwayFarm indexer. Sorry for keystrokes. I try to type as soft as possible, but I know you still hear them. So it asks us which languages you'd like to use, and we support 3 languages. Like JavaScript is the plain one, TypeScript, which is a default recommended version. It's the best one because you have types provided, so it's pretty much safe. And for the really geek developers, there is ReScript option, which is even more type safe language than TypeScript, but we will skip it for now and stick with TypeScript because most of the people understand it. I think my terminal broken, so let's clear it. Let's also adjust the size and try again. Full demo, SwayFarm indexer, TypeScript. Yeah, I think I just didn't reload it for quite some time. Envio supports 2 ecosystems. It's EVM ecosystem. There are a bunch of chains supported for it, and also Fuel. And we have multiple initialization options. The first one is template. We have a greeter template, which is the best to familiarize yourself with the Envio and to play around with an existing indexer. But now we already know what we are doing. At least I know, and I hope that after this demo you'll also know. We choose contract import, and for EVM we have a cool feature where you can paste your address and we'll fetch the API and everything from the block explorer. And Fuel doesn't have this yet, but I know that Fuel team built a really cool feature where they going to store APIs and contracts on chain or something like this. So it will allow to verify contracts and also allow us to implement this feature for Fuel. So maybe if you come to Envio a little bit later, we will already have this. And the only thing you'll need is to simply paste a contract address and everything will work without additional steps. But now we just manually enter a path to, sorry, my throat is sore. Manually paste a path to the API, and there is nice auto completion. And the API is located. I have this project open quite close. You can also clone it from the GitHub repository. Let me send you a link. So maybe it will be interesting for someone. Okay, I'm here. And if you have a Sway contract, you can find an API in the out debug directory. If you don't see the out debug directory, you can create it by running fork build. Fork is a build system for Sway language, and Sway language is a language for building on Fuel. A little bit confusing for newcomers, and it was also confusing for me for some time. We enter a path to the API, and here it automatically parses it and says, this contract emits this list of events. Which one do you want to use? And let's press left to unselect everything and think, okay, we want to build a leaderboard for the SwayFarm. And in the leaderboard, what we want to have, for example, we want to have a list of players, and the player should have an ID, it should have a skill level, as a number of points, like how many plants they sold. And let's just have a timestamp when the player was created. And it's like a good example of how we can use indexer to get the data which is not stored on the actual contract, because the creation date is not stored on the contract. So that's a really good case to show. So to implement this, we need only 3 events. First one is the creation of a player, which is new player. Another one is level up once the level increases, and sell items, because at this point the player points increase. Press enter, and it asks us for the name of the contract. Let's call it SwayFarm, and the address of the contract. I have it prepared here, so I paste it here. If you don't know where to find it, I personally found it from the extracting network, from the network request of this application. But usually when you deploy your contract, it shows you contract address, so you can use it later. Envio also supports multiple contracts and multiple chains, but currently we'll have only one chain, which is testnet, so it's not really relevant, and just current contract SwayFarm and network fuel, and we are finished. Also, we can create an API token for the hypersync, our internal tool to use. We can press enter, and here you can either create a token or copy existing one, so it's super simple. And then you can paste it here, but let's skip the step because I don't want to show my API token. And that's all. I think if I didn't describe all the steps, it would take something like a minute. And after creating the project, we can open it in our terminal. So let's, I call it SwayFarm, cool name. Okay, here's the indexer project, and there are quite many files, but there are only 3 which are actually interesting for us and which are the core of the indexer. So the first one is the config. It has a nice JSON schema for auto-completion and validation, so you won't be lost here. And here we can see pretty much everything that we entered during the initialization step, and you can extend it later with some additional events. For example, if you want to index more data, or if you want to add more contracts, you can add it here and regenerate the project. But now we don't need to change anything here. And I'll show you the next important file. It's event handlers. And here by default, we generate handlers for all the events. So actually we can already run this indexer and it will work, but it just won't have the data we want. Here, what we'll need and what we have here is our 3 handler callbacks. When an indexer processes the new player event, this function is called. When it processes the level up handler, this function is called. And inside of it, you can get the event data. For example, inside of the event, it has the data field, and inside of the data, it has the address field, which is typed and have nice auto-completion, so all the types and automatically generated. Also, address field is a union, and it contains payload, which is bits. So we can, this way, we can get an address of the user of the player. So it's pretty nice. And if you do a typo, TypeScript will complain. You don't need to care about anything, just get the data of the event, or for example, you can also have the transaction data or block data. And then we have some helpers to work with the database. And it's really optimized because it does batching, like it have in-memory caching. So everything to make the indexer work as much as possible and have the most simple and developer experience. And also another file is, okay, unsave this. Schema GraphQL, it's the place where you describe all the entities you're going to have in your database, and then these entities are exposed to you via a GraphQL endpoint, or like we use Hasura, and Hasura also allows you to have a REST API. So anything you want, like in any convenient format you want. And I think let's start working on it. And the first thing we want, if we want to show and provide players via our API, we need to create an entity for it. So let's create a player entity. And my AI suggested an autocomplete, which is you can usually see for the subgraphs, but we don't need this add entity attribute. So we need to add this ID field. Let's have created add. Let's have it number. Also, I don't remember other fields, but what we can do, we can go to the contract and see which data even emitted by the events we're going to handle now. And also, I want to show how it looks like from the contract side. And do you remember I was saying that you can log literally anything? And here you can see that there is this log function that says log any stack type, like some documentation. And here you can see that it logs a cell item struct, and inside of it, there's like the sender, which is identity. Inside of it, there is amount, and there is amount to mint. Also, there is another struct nested in it, which is player. And what we are interested in it is actually the player. And player has on storage the farming skill and total value sold. And you can see it doesn't have the created add. So it's a shame, but we can solve this with an indexer. So let's change sometimes. U64, it's a big int to have save data. Also, let's change the snake case to camel case, because this is how things done in the crypto ecosystem. And I think that's all. So to continue, what we need to do is to run npm code again, and it finished. And after code again, it started complaining on, let me close everything so we have better visibility. It started complaining that some imports doesn't exist. Also, it complained on types and other things. So it's really good in terms of type safety. And also it created a nice type for us, which is player. And you can see that it's created add, farming, skill ID, and total value sold fields, which we can use for entity. And let's start with a new player handler, comment everything out, and start setting a new player. Create it here and put it to the set function. So how to create a player? We need an ID, and for a player ID, I want to use the actual player ID, like the identifier, the address of the user who called the contract to create the player. And it's event, data, address, payload, bits. Also, it has created add, and we can get it from the event type. This is the time of the block when the transaction happened. was processed, sorry. And also we want farming skill, which is not included in the new player event, but we know that by default it's 1, and total value sold by default is 0. So that's it, and pretty nice. So a few more lines of code we need to write is handlers for other events. So let's copy paste it for the new player event and adjust it a little bit. Here we can get a player info from the event as well. And this is stored in the data player info. Yeah, like this. And from player info, we can get farming skill and also we can get total value sold. And we don't need to do any casting because it decoded as begin and we store it as begin. So that's pretty nice. There's only thing that we don't want to overwrite created at. So let's fix it. And to do this, we need to get existing player. And if there is existing player, I need to await this. If there is existing player, instead of setting ID and created at, let's spread the values from the existing one. And I will write it with set because set overrides the existing value. So we don't want to lose the created at. So that's it. To not spend additional time to trying to remove code duplication, I just copy paste it to the cell item logic. And we are finished. And let's open the terminal here because it's beer. And what we need to do now is to just call pnpm dev. And it will prepare the database and Hasura for running. And here we can see that it started working. We have almost 9 million blocks on the chain. The last time I did the demo, it was 5 million blocks, so it's increased to false. And it's indexing, and it says 3 minutes left. And it already processed 10% of the chain where 100 events processed. And while it's processing, let's take a look whether we have some more comments or not. How can we configure this for an existing project? I think, I might be wrong misunderstanding what you mean, but if you have an existing project and an existing contract, what you can do, you can run fork build to get the API of the contract and follow the same steps I just done, and it will create pretty much the same indexer as I've shown. And also we have what I'm doing. I've written down a text guide. You can find it on our documentation, which describes pretty much what I'm doing right now in the written format. So maybe it will be more understandable for you. So I shared the link here. Yeah, I know that organizers share the recording. So I think it should finish it. No, the number of events increased. So it will take some time. But in the meantime, we can go to this GraphQL endpoint and see what we have. And we use Hasura for managing all this API stuff. And it will ask you to write the password. A password is testing. I'll also write it down just in case somebody repeats and does the steps with me. And here, we have a really nice GraphQL playground, which you can use to experiment with the data. Also, there is a data tab where you can see the raw database, how the data is stored. But for the demo, I've prepared a really interesting query, which can showcase what we've done here. So let's copy paste and see how it looks like. And what is the query is, first it gets inactive players, and it does it by aggregating the players and filtering the ones with the total value sold 0. So users who were created but didn't sell anything. And we can see that there is like, we indexed only 25% of the chain, but there is already almost 200 inactive players. Also, we have a query for active players where we do the opposite. We query users which have something sold, and we get a count and average farming skill created that. So like the interesting stuff to take a look. And we can see that an average, probably I messed up something with the logic. So let's take a look at the farming skill. Below I show the top 5 players, which is a query with limit and also using order by. Also, if you want, you can get users by ID. So it's also one of the common response or like use cases. And see that less than 100 milliseconds, and this is quite complex one because it like does aggregation on the whole, like 2 aggregations on the whole database. And so it's definitely faster than doing a request directly to the smart contract. We can see that we can get the top 5 players. We can aggregate some entities, get entity by ID. It's like really raw GraphQL you can use in any way you want. And how's the progress? It says that 2 minutes left. Cool. Now what I want to do is to show, you that it's like cool that it works locally, but all this indexer is a quite complex setup with Hasura database and also the whole service itself, because it doesn't stop running after indexing all the historical data. It continues running, and when a new event occurs, it processes it and sets to the database. So it's 3 separate processes. And now I want to deploy how you can deploy it. And for deploying it, you can use our hosted service. So we can open it. And what we need to do, let's click add a new indexer. And to add a new indexer, we simply can connect a Git repository. And to connect a Git repository, we need to create a new one. So let's create a new repository, call it SwayFarm indexer, public one, don't need anything. And what we need to do is let's copy paste this one. Cancel this. I need another terminal. So you need a repository. Select everything and create the first commit. So now I have this code. Do I have this? No. Probably the problem is that I have 2 repositories called the same. Let's try to do other steps. Okay, I think I failed on creating a repository. Actually, I see that we are already out of time, but so I'll just simply describe how it's done. You create a repository, commit the code there, then on the hosted service, where is this? On the hosted service, you find the repository in the list, click connect. Here, there is a simple configuration. You don't need to change anything actually. And it's one of my libraries. So let's create a project with it. And I get an error. Okay, I won't debug this. Probably the problem is that it's not an indexer at all. So you create connect a repository, add permissions, and you simply push to the Envio branch. Then it builds the indexer and runs it on the hosted service. Currently, it's free, and feel free to experiment with it. And yeah, and you can see that there are multiple projects using it. And I want to finish my presentation with some last slides saying that we are used by companies building on Fuel, and I think many of you could hear about Spark, which I think one of the biggest existing applications on Fuel currently. And they are using our hosted service, and they are using our indexer, and they use it for all this EU user interface for trading and etc. Also, I know other products like Thunder Exchange and Swayland, and I don't remember another name. Some developers use it, and yeah, and it's only a list of the Fuel teams. So also quite many teams using it for EVM, and we are going to actually merge them, I think this week, into a single code base. So EVM and Fuel will be like solidified and have the same features, such as wildcard indexing for Fuel, also multiple receipt types, and etc. And I think that's all. Still, if you have any questions, feel free to ask them in the chat section. Demo codes weren't on my site today, but usually it works. And if it doesn't, come to our Discord channel, and we help everyone there quite fast. And I'm going to share. I think I have Jordi on the channel who can share the link, but I also share this one for the ones interested in. Unfortunately, I don't have Discord link here, but this is where we are the most active.
For everyone else that is watching right now or live, this will be recorded. It already is, and we will make the recording made available in the next 24 hours. We'll make sure to post it both on Discord as well as the Hacker Pack, which we keep on reminding you about. Links are going to be shared early in the morning tomorrow, depending on where you live, but roughly within the next 24 hours. And there's some additional, I think, messages coming in. Yep. Mostly thanks again to you, Dimitri. Thank you for the nice presentation overview. And yeah, we do have time, by the way. So if you want to do any final notes, we are ready and flexible.
I think final notes that I feel like I have two final words. Fuel is cool. I've built several contracts for testing our indexer, and I really enjoyed the Sway language and like the team behind it and how fast everything works and progresses. So it's really cool. And also I want to say that don't be shy to try out Envio, because it's a really cool product, and I'm really proud of the thing we've built, and I can brag about this without any shy.
Absolutely. Thank you again. And a few last bits from me as well. Don't forget to tune in on Wednesday when we're going to have another workshop. It's going to be a TypeScript and Rust SDK office hours. So for those of you that are building already, or those of you that are running into issues, make sure to tune in. Make sure to share all of your questions, and we'll have representatives from Fuel that will be coming in and helping you out with all the issues that you might be having. There will be also several presentations as well included, with the sole goal to help you out and achieving and building the projects that you have in mind. And speaking of that, once again, a reminder that this Sunday will be the deadline for you to submit your idea. Again, this is just an idea submission, which means that mostly just give us present to us what you're planning to build, and we will make sure to connect with the right people and help you out with achieving your goal of making this idea a project and a submission by the end of it. And who knows, maybe we win a prize. Again, Thank you for being here. Thank you, Dimitri. Thank you, the Envio team, for coming in, supporting. It was great to have you once again. And yeah, looking forward to seeing you all on Wednesday. Have a great day, everybody.
Yeah, have a good day.
See you.